Yeah.
And if I do this, you can still see my screen.
Yes.
Awesome.
Yep. Speech to text on the bottom of the slides is nice. I like that feature too.
Yeah, the only problem is that if it's based in PowerPoint, it does not help
When you go to
when I go
demos.
to my demo.
Yeah.
I don't think that Zoom has a speech to text feature
No.
built in though, right?
No, not yet anyways. They might one day.
Well, we can't all be Teams, but
Nobody
yeah.
ever has it turned on in Teams though.
it can
When
be.
I do events, it's not turned on. Just speaking of maybe an event I did recently or two. They were in
Oh, yeah?
Teams and my slide deck had to do the translation. So
All right, let me put this back.
maybe they don't know it's there. Is that a recent addition? You know, because you're a Microsoft.
You know, I think it's recent as in like the last pandemic.
Well, yeah, that's
Wow.
kind of what I meant by sort of recent, like last 6 months is what I was thinking.
Yeah, I know they've been
I
racing
figured
out
it probably got added because of the pandemic, maybe.
They've been racing out a bunch of new features, and MVP Summit in the beginning of April or the end of March.
Yeah.
They had released a ton of new features, including the PowerPoint Live thing, where it actually rehosts the PowerPoint locally and then passes along commands instead of streaming a screen. And so it uses 90% less bandwidth, and it looks a lot better, and the animations play at like 25 frames per second and stuff like that.
Wow. Yeah.
Yeah.
My favorite's the slow transition where it's like struggling. So I love the 25%. That's awesome.
It like glyphs between a transition of slides, and like some of the stuff that changed is there, but the other stuff is just like corrupted. Yeah, that's awesome. But no, that's how they fixed it. So PowerPoint Live in Teams, and like don't tell Zoom I'm talking about Teams on their meeting. But
The call just
I
ends.
think they hear it as you're translating.
they're listening. They're listening. But yeah, that's how they solve some bandwidth issues in Teams, is that whenever you're sharing a PowerPoint, it actually downloads it to your side, and then it just receives commands to go back and forth. And in fact, the speaker can enable a mode where individual attendees can hop through your slide deck without you, and then go back to wherever the presenter is at any time. Because it's hosted locally. It's not streamed over a screen, so it looks a lot better and it uses less bandwidth. And so if you're a bandwidth limited person, you can still share your video and receive video and share a PowerPoint at the same time. Now, it doesn't help you when you drop out to a demo, unfortunately, because that's outside of PowerPoint. But at that point, you got to go back to a shared screen. But yeah, it helps. It helps a lot. In some of the other presentations I've been doing, especially inside Microsoft, I'm just building everything into PowerPoint as much as possible, step by steps and animations to save having to get out of PowerPoint at this point. So because it just works so well.
I love that. And it's great too, because I feel like in a lot of presentations, I'm always like, oh wait, what was that last thing they just said? Or like, what did that look like? So it's like, you know, you don't want to ask that question for it. So you can just like zip on back, grab that info, still be listening through the whole thing. That's really cool.
Or like the inevitable question that you get like right after the slide where it says, this is going to be available at my blog to download here. Somebody will ask, is this available for download? They could just go back to the last slide.
I love that. Oh, that does remind me though. So we're going to be requesting all slides from people. Of course, if you want to link to your website, okay there. But just so you know, the recordings and the slides, we're going to do our best to make them available to everyone. If we can't source any of them for our recording launch, we'll definitely shoot out an email, let people know when additional ones become available. But definitely the bulk of them will be available with the recordings in a little bit. I have to edit them. So however long it takes me to do that.
Yeah, great. How should we send our presentations to you?
However you'd like. I'm just going to shoot off an email. We take a few approaches. We can say, would you like us to host it in Google Drive for you? Link directly to your blog where you have it available. Really just whatever makes it easier on your end. We'll make it work from our end, because we know that chasing people down for slide decks, it's not the most fun thing to ask for. So we'll do like however you want to get them to me. That works great. And we'll just kind of go from there for it.
It's already hosted on GitHub, so I can just
Bam.
send you a link to it, and you can
Mine's
link to
already
it.
on
Love
my
that.
website if I ever do anything. So save
Bam,
Google.
bam, bam. Slides on
Bam.
slides on slides. Yeah, I love the GitHub format because I just drop it right in that YouTube description. People dive on in there and it makes life so much easier. So perfect.
Perfect.
I love it. I feel like I need to get a GitHub just so I can, when people don't put it in GitHub, just put it in GitHub to make life a little easier. But then I'm just going to be like a dragon hoarding speaker slides for presentations I haven't actually done in my GitHub, and that's it.
Yeah. I keep
All
them
right,
on my
so we got 4
website just
minutes
for
left.
easier.
Mhm.
It's easier for me to keep them on the website because I put a YouTube link to mine if they've been recorded to the one I think was the best.
Ooh, one-stop shop. I love that.
So you can go there and see the thing and the most current slide deck.
You
Most
kind of
current
do a
slide
little
deck
side
may
by
or may
side.
not necessarily match the recording, but it's pretty close.
With a few tweaks here and there, maybe. I
It
mean,
may
that's
have
the
newer
best part.
scripts and things like that, but it's
Oh,
pretty
that's
close.
so good. All right, so I am going to just hop over to the other track, say hi, see how everyone's doing. But William, you are going to kill it. We're so excited for your session. Thank you for joining us. Tracy, thank you for moderating. Anything you need, you're in my ear. And just thanks again. We'll talk to you soon.
All
Yep,
right.
thanks.
Have fun on your side.
So we have about 3 minutes, right?
Yes, 3 minutes. And then the fun begins. The heckling. Oh, I'm just kidding.
Well, that's why you were talking about heckling me earlier. I was like, oh, okay, that's cool, Tracy. Just random
How else
heckling,
am I going to do it? I have a mic.
random threats of heckling. And now I understand that you're my co-host. You're my moderator.
Yeah, I got you, and then I get a break, and then I've got Dakota later. So I offered to just do 3 in a row, but they told me no. So they had me do 4 in a row one day. So I just sat here like all afternoon, and then I stood up on the desk, and then I sat back down. And they're like, no, we got someone to do at least 1. So I was like, oh, okay. It was worded confusingly, like they might need 3, they might need 2. So I was like,
So you're seeing my lab now, right? Oh, and if I go back,
I was, but then you did that.
yeah, so now you're just seeing the lab. Okay,
Yep.
I think I'm gonna do that to switch back and forth. Ooh, what if there's a way? Let's try to troubleshoot things right before I go live. That's always a smart idea.
Well, that's what I do. Oh, well, I do worse. When I do my DBA tools and DBA checks presentation, I update like an hour before the presentation, the module, and we see if anything breaks
Yeah,
during the presentation. Because, you know, they're
Yeah.
constantly fixing code in DBA tools.
I always like to just reinstall my operating system right before my live demo. It's real helpful.
I let the updates run if I get on there early enough. And go ahead
Yeah.
and install the latest service pack. Why not?
So I actually think this is working. So hey, we figured it out, chat. I'm just gonna,
Wow.
I've put my lab in front of the full screen PowerPoint, and now I've got transcription and my lab demo going. How about that? Nothing could possibly go wrong when it actually comes time to present this. So great.
That's cool.
All right.
All right, we got 1 minute. You feel
Well,
the
cool.
pressure? I'm just kidding. Don't feel any pressure.
No, I'm good.
You're gonna do just fine. You're a pro. You know I'm just heckling you, so
I do.
I warned you earlier. You had a warning. You just didn't know what it was for.
Can't say I haven't been warned. Yeah.
All right, I'm gonna go on mute. It's all yours.
Cool. You have a script or anything to do intro, or is it just me?
No, if they didn't give me anything,
Awesome.
I could
That
try.
works. Ah. All right. Well, cool. Welcome everybody. Welcome to GroupBy. It's an honor to have been voted to speak again. This is actually my second GroupBy conference, and it was the same presentation. This presentation that won a spot in a GroupBy conference in October of 2019 as well. You know, in the before times. Since then, since that happened, I've moved on from about 14 years or so of SQL Server consulting into a senior content developer spot at Microsoft on the SQL Docs team, where I help maintain the documentation for SQL products across Microsoft, specializing in docs on SQL performance, Azure SQL Database, Big Data Clusters, Polybase, and Azure Synapse Analytics. So I'm really looking forward to sharing this presentation with you today. It's a talk where some of the content and most of the jokes are very old, but I always refresh the content, but not the jokes, with the latest DMVs and SQL features. And so especially at the end, when I start going through rapid fire through a bunch of DMVs, we're going to get to a lot of stuff that had been introduced in SQL 2019. My co-host Tracy will be handling the Q&A for this session. I'm going to pause regularly throughout the session for fielding questions, and hopefully we'll have plenty of time for Q&A at the end as well. This presentation usually runs long. It has a ton of labs and demos, and so most of which I'm going to skip. I'm going to do that for a couple of reasons. One, for time, and the other because these demos and these labs are really most valuable to you and your learning when you run them on your own in your own SQL instances. I highly recommend getting to know your workloads and your SQL Server maintenance patterns hands-on via these DMVs. So forgive me if I don't spend a lot of time showing you someone else's data on a laptop or something like that that doesn't really have a lot of activity. Instead, these DMVs should be baselined and observed on your systems as you grow as a database developer and administrator. So let's go ahead and get started. Everyone can benefit from the knowledge of these helpful tools, from developers to report writers to DBAs of all levels of experience. So if you fit into any of those categories, welcome. I think you're going to learn something from this presentation. There are far too many DMVs to be covered in the scope of a presentation. Here are the most useful, the most popular, my personal favorites, for example. Getting anything out of these DMVs, again, will require you to try them on yourself. And I'm going to have a lot of labs. We won't get to all of them. They'll actually be marked in the presentation. So you can actually go through the presentation, run the labs yourself. And we're going to have these practical scripts that come from my background in consulting to share. I'm going to stop for questions throughout. Save your questions for the chat. Now, hopefully I'll be able to get to them in the middle or toward the end. All the presentation slides and all the samples are always going to be posted at my blog right there. And they're actually going to be referencing a GitHub repository of sample scripts. And you just look for the sample script with that name in it. And that's what I'm talking about. Some of the tables that I'm using are going to be provided, using the Microsoft provided Wide World Importer sample database. That's also available for download on GitHub. It's pretty easy to find and download and restore a lab of a database on your own. And a lot of the code, again, for this presentation is going to be in this GitHub library SQL Server toolbox from my previous consulting team's SQL toolbox, a toolbox that I built and maintained for the better part of a decade as a consulting DBA. And it's out there for free for everyone's reference. So one question I have not answered yet is, what is a DMV? Here's where the jokes begin. So is it the Department of Motor Vehicles? No. Is it the DMV proxy service? Brilliant idea. No. Is it the DMV motor mega musical starring only just one of the Blue Men? No, it's not that. Is the DMZ? No. Is it Run DMC? No. Is it the Greater DC Maryland Virginia Rhapsody? No. Is it no, it's DMB. Dynamic management views are in place to provide system transparency. And most of these are actually dynamic management objects, and they work all the way back to SQL 2005 or version 90 internally. And again, most of this content applies to SQL Server, but also to Azure SQL Database, SQL on Linux, Azure SQL Managed Instances as well. The DMVs that we're talking about today are the foundation of countless third-party SQL monitoring applications, and they all fall into a category of DMOs, dynamic management objects. Some of these are dynamic management functions in that they have parameters and they provide a table result as the outcome. But for these purposes, I'm going to call them all DMVs because we can make more jokes about DMVs. But they could also be called DMOs, dynamic management objects. But that's actually already taken by distributed management objects, DMOs. So it's actually kind of confusing to use DMOs. So DMVs is still an acceptable way to describe them all. Some DMVs require the database be in the needed compatibility mode or higher. Some do not. They just care about the version of the server. Some toward the end of this presentation have been introduced more recently, including in SQL 2019. And so they'll only work in Azure SQL Database or in SQL 2019 for the most part. How often DMV changes are introduced in older versions via service packs or cumulative updates. Something may not work in SQL Server 2012 Service Pack 3, but it may work in SQL Server 2012 Service Pack 4. for example. And just a reminder, SQL Server 2012 extended support expires next July. So you have about 14 months to get that upgrade and migration plan in place for SQL 2012. But not to get your anxiety too high, go ahead and relax and enjoy the rest of this presentation. Most of these DMVs require only one of these permissions, view server state or view database state. You do not have to be a sysadmin to get this information, this read-only permissions information out of a SQL Server. So most of these DMVs are completely appropriate to give to developers, even in production, because they do not and they cannot get access to data, only metadata about the SQL Server's performance and maintenance patterns and things like that. And so it's actually quite easy to grant these permissions to anybody, even if they're not sysadmins or if they're, for regulatory reasons, barred from having read access to the data. Okay, so again, I'm going to go pretty fast. I'm going to cover 3 big topics when it comes to DMVs and maintenance. This presentation is called Best Practices for Maintenance with DMVs. We're going to talk a lot about performance and maintenance, and then we're going to go through a whole bunch of other DMVs that are just going to be super useful, but we're going to go through them faster. Again, I'm going to have some pauses for breaks in the middle. So let's go ahead and get started. The first set of DMVs we're going to talk about have to do with weight stats. So many performance suites incorporate little more than these DMVs. In fact, most just incorporate the first one, just the weight stats data that is aggregate. But again, all of these third-party performance suites and software platforms and monitoring tools and monitoring solutions and enterprise monitoring suites, these are all fantastic sponsors of user groups and tech events and GroupBy and SQL Saturday or whatever becomes of that. So it's great. And a lot of times what those third-party applications do is they'll put a pretty picture on the numbers and they'll warehouse the numbers for you over time. They'll track the numbers over time, and the good ones will also correlate it with other DMVs, but they do not have magical access to your SQL Server. You can get access to the same data, roll your own monitoring suites if you want, collect that same data, slap it into Excel, and you've got monitoring tools. And I've been saying this since before I was a Microsoft employee, and when I was a consultant, I couldn't sell my consulting services if I was also requiring them to go buy whatever monitoring tool was out there or whatever monitoring tool was sponsoring. So even as a consultant, I wasn't really selling any of the monitoring tools. These were the monitoring tools that I helped sell, and this is how I came to learn all the stuff about DMVs that you can too. So let's talk about weight stats. The first one, DMOS weight stats. This is aggregated wait times. It records when something has to wait in SQL Server, and then it retains that event and the duration. The count of times and the sum of times and the max time, there are over 1,100, more or less documented. We're working on that actually. Wait types in SQL 2019. But it's best to exclude a wide swath of these wait types. For example, things that have the word sleep in them, because those are related to database startup waits or background task waits or idle activity, and they're not really considered important when it comes to measuring SQL Server performance. In fact, there are a bunch of wait types that you're going to want to ignore, things like on-demand task queue and a whole bunch of stuff that looks like this and other permutations of that. And there's actually a really good resource on SQLskills.com for wait statistics that you can safely ignore because they're not a problem if they're very high. It probably just means your laptop SQL Server instance wasn't doing very much, right? So let's talk about some of the wait stats that you actually do want to care about. Anything that has LCK and an M and then anything after that, there's a bunch of different types of that. This is a sign of transaction contention. This has to do with pessimistic locking, which is the core of any relational database system. You can observe these locks that are actually happen in SysDM tran locks over time. That data is kind of difficult to consume. There's a lot of it. It could be that they have poor queries, poor indexing, creating too many scans that block other requests, especially scans that block writes and writes that block reads. Synchronous availability group replicas could increase lock weights of this type. And if you have a lot of lock weights in this type, you have the classic contention issues that anybody with a relational database system might have, where reads are blocking writes and sometimes vice versa. Consider the enterprise solution for concurrency issues, which is RCSI. the read committed snapshot isolation. And consider this instead of just slapping with no lock at the end of your code or with the read uncommitted at the beginning of a stored procedure. Both of those are anti-patterns. You do not want to do that. The enterprise solution for locking, for hitting the turbo button on your 486 of database is RCSI. Yes, you do have to be aware of the impact to TempDB. TempDB is going to increase. TempDB is already going to be the IO bottleneck for your database to begin with. So put your fastest storage behind your TempDB. That's a topic for a completely other presentation, but let's keep moving on. We're talking about wait stats. CX packet. So CX packet is a clear indication of excessive execution plan parallelism. Plan parallelism is not itself a problem. It's actually good. Things run faster in a vacuum when they go parallel, but excessive parallelism means the CPU is struggling to catch up with too much parallel activity. So you want to look to your max stop settings, and there's a bunch of different ways to enforce max stop settings these days. Max stop can be configured server-wide, but in recent versions, you can configure it at the query level with a hint that requires code changes, but you can also configure it at a database level. This would have been super helpful many years ago when SharePoint required that all its databases run in max stop 1, but you had other databases on that very expensive enterprise version of SQL Server you wanted to run. It used to be that you could only enforce max stop at the instance level, but now you can do it at the database level. You can also do it at the resource governor level, which was our solution back then, is to enable max stop at the query connection time. So when you can identify queries coming into your SQL Server based on certain characteristics of their connection, like their login name, their host name, or things like that, you can enforce a max stop at that point. That's actually one of the better implementations of the resource governor, which is an enterprise-only feature. CX packet has recently been split into 2 different wait types. And so when you did an upgrade from SQL 2014 to 17, for example, CX packet actually probably changed a whole bunch, and it's important to understand the context there. So CX packet used to be from threads that both consume and produce query plan data. This is an oversimplification, but you don't really need to understand it past this. Producer threads were actually the more problematic, most impacted by parallelism, and most affected by things like out-of-date statistics that caused problems. So now only those producer threads are reported by CX packet. The consumer threads, the ones you have less control over and are less important, are now reported by a different wait type called CX consumer. So CX packet will have gone down. It doesn't necessarily mean you have solved your parallelism issues. So as a result, in these versions, remember how I mentioned that they roll back some of these wait type changes in service packs or cumulative updates. CX packet will be lower, but you haven't actually touched your parallelism issue in that case. You just have a more clear picture of what it is you're looking at. Let's talk about a couple more wait issues. OLADB describes waits associated with external communication via an OLADB provider. Most often this is caused by SSIS, but it could also be caused by Microsoft Office applications that communicate over OLADB drivers, or linked servers that use OLADB drivers, or other third-party tools. Also, DBCC CheckDB can run up a whole bunch of OLADB provider waits. So be aware of that and try to time that out. SOS scheduler yield is a clear indication of CPU pressure. When this is the highest wait, you have too many runnable tasks for available threads. Yes, adding more CPUs could help lower this. More likely, you're going to want to look for and reduce CPU-intensive queries. How do you identify CPU-intense queries? There's a DMV for that. We'll talk about it. Resource semaphore. This is a request waiting on memory to be gathered before starting. It's an indication of memory pressure. It could be caused by insufficient system memory, and adding more memory could help. More likely, it's caused by poor query design, poor indexing, so you have a lot of scans happening instead of seeks, inefficient execution plans, much more likely to be causing something like this. Or just otherwise outside memory pressure outside a SQL Server. And then some page latch. Let's talk a little bit about page latch stuff. So page latch without the IO in the middle, completely different from the page IO latch. So page latch has nothing to do with physical IO. It has all about contention over a page in memory. We're actually going to talk about one really specific and common scenario for this in the next slide. But for now, page IO latch has all to do about physical IO, reading data from a disk or an SSD. I understand, but disk is the storage sublayer. So the hard disk or the SAN or the SSD or whatever you have underneath the SQL Server is potentially struggling to keep up. Again, often this is because of inefficient application code, not actually a problem with the disk, but it does tell you where your current bottleneck is. Oftentimes, it can be caused by things like MS access, which would be the very definition of inefficient application code, querying an entire database table via a linked table or something like that. Let's talk about one specific issue with page latch, though. Again, this is back to talking about memory. And there's a common issue where you had a hotspot in memory in TempDB, and it had to do with a whole bunch of it had to do with sequential updates where everything is trying to write at the one page because you have a sequential key. And that was not a good enough argument for me to not use a sequential key. It was just kind of a cost of doing business. Well, now in SQL 2019, there's a new index option called Optimize for Sequential Key. It is specifically for tables who have a clustered index that use an identity or a sequence because of hotspots for sequential inserts. You have 10 different threads trying to insert the next row, and they're all trying to grab the next ID. They're all trying to get that one page. If you observe high amounts of page latch EX exclusive, it may be because this contention for individual pages is due to concurrent sequential inserts, and specifying this hint when creating the index. So like when you create the table or when you alter the index to provide this hint, you can actually improve performance up to 30% for those concurrent inserts. And you want to add this to any key that has a sequential number behind it in the first key. This is a pretty big deal. This is a selling point of SQL 2019, in my humble opinion. This is definitely something you're going to want to take advantage of in Azure SQL Database or in SQL 2019 if you have those installations handy. All right, let's talk about a couple more wait stats and then we're going to move on. So async IO, this is waiting for disk IO to complete, not related to data pages. So this could be due to growth or writes to log files, backups and restores, auto growth events. In general, some of those are good, some of those are bad. You want backups and restores running up this thing. It means those are happening. You don't necessarily want to see a lot of auto growth events causing async IO completion. So some of this is expected. Some of this could be a tip-off that you have a bunch of things that are growing and you want to go look at your auto growth history. Async network IO, on the other hand, is caused by waits involving the reception of data by remote clients. Almost certainly this is not caused by the network. I've actually once in many years seen this actually caused by a bad switch. There was like a cable loose or something like that in the switch, the client told me. Most of the time this is caused by inefficient queries where, for example, you're doing a select star, you're doing something without a where clause, and the client is having to receive a ton of data and then do client-side filtering. So you're going to want to look for queries with high row counts. And often this is caused, again, by Microsoft Office applications, including Access, which just want to pull the entire table in without a filter. They don't do any client-side filtering. That's a bad idea. This can also be caused by applications that don't do paging very well. For example, when you search a Bing or Google for something and you come back with 10 billion results, it doesn't give you all 10 billion results when it renders the page. It just gives you the first 10. Imagine async network IO would require all 10 billion results to come back before it could present you the first 10. That's bad paging, and that's something that could be happening to your SQL Server. That's a scenario to look for. Okay, so wait stats. When do you analyze this stuff? You want to use this on healthy or troubled systems. So all systems. Look for trending from a baseline. So start capturing this data, refresh the data regularly, start capturing this over time. This is something that a lot of these third-party performance suites do for you. They show you your weights types week over week or day over day. That's great. You could do that too, just using this DMV in your own tables. This helps you determine what weights are impacting the performance. And this is server-wide, instance-wide. Server's not corrected there, instance-wide. And it's one of the best DMVs for getting a picture of instance-wide performance. What is my bottleneck? What is the thing that is keeping me down? If it's CX packet, then I know what to attack first. And as a consulting DBA, that information was pretty important to me when I was trying to do a performance tuning exercise. So the numbers coming out of this DMV are a forever growing aggregate. And so over time, recent changes will not affect that large aggregate very much, right? So a recent change that happened last week is not going to make that much of a dent in numbers that have been growing for the last year, something like that, right? So for your performance sensitive servers, your prod boxes, stuff like that, consider a regimen of storing the numbers every week or every day or something like that, and then comparing the difference over time. So you can actually see how weight stats are changing. That's how a lot of these performance tracking third-party applications do it as well. And so again, this is aggregated at the instance level. It doesn't give you a live picture of what's going on. It doesn't give you a request or session level data. For that, you're going to need the next DMV, and that, my friends, was a segue. The next DMV, DMOS waiting tasks, shows waits for current active requests that are not aggregated. This is not much different from the current wait stats information you get out of sysdm exec requests, one of my favorite DMVs that we're going to talk a lot more about later. Instead, let's talk about DM exec session wait stats. This is actually relatively new, and this shows waits for the current session. So a connection coming from an application will have all its session wait stats aggregated until it disconnects, right? And so for applications that reuse connection pooling, this is a great way to go and see what waits am I getting out of this specific connection coming from an application. And it's a way to filter out a lot of other noise, things like backups and DBCC check DBs and stuff like that. So its syntax is the same as the aggregated DMOS wait stats, but it includes an extra column for session ID. And this is one of the labs we're not going to do, but I definitely encourage you to explore these things. And again, these are available at sqltac.com to download, and go to that toolbox and you can get scripts that have these names, and you can go and explore this data on your instance, start baselining it and measuring it over time. Very important stuff. So we've already talked about a couple DMVs that link to other things to get live connections and get information about the queries that are happening now. Let's talk more about those. So sysdm exec query stats stores performance information about cached query plans in memory. So this isn't live, but this has to do with what's happened recently. The rows don't persist after a plan is removed from cache. So, or for example, you restart the SQL instance. And what it does is it provides you two columns that are pretty important. You're going to use them a lot when you start writing your own DMV queries: SQL handle and then offsets that start and begin. These help you identify as statements. They help you identify the lines by characters inside a batch. For example, inside a stored procedure, you got a 10,000 line stored procedure. Well, what's actually causing the stored procedure to run slow? Which of these statements that happen, it could be many statements that happen inside of a stored procedure, which of these things are actually the problem? So when you join a bunch of different DMVs that provide the SQL handle and the offsets to sysdm exec SQL text, and there's lots of examples in the toolbox of this stuff, you can actually get the individual statements out of a large batch of queries. And so DM exec query stats can help you find the worst query plans in terms of total worker time, CPU, we talked about that earlier. In terms of rows affected, we talked about wanting to look for that. In terms of duration, who doesn't want to find the longest running queries? This is really useful information, but hold on. It records all sorts of things, and there is a lab out there called Worst Query Plans. And for a long time, before 2016, worstqueryplans.sql was like the go-to script for my consulting team. It's the go-to script or something like it for the Tiger team, for SQL Server, for Microsoft. But when SQL 2016 came out, there's this thing called the Query Store. And this feature actually contains more and better data and functionality than the worst query plans. And it's so good that I actually rarely use the worst query plan script unless I'm working on a SQL 2012 or 14 box. Because in anything SQL 2016 and above, you're going to want to go and enable the Query Store. Keep in mind that it's not enabled by default because it does take up a footprint of storage and some overhead for memory, but it's definitely worth it for a performance sensitive database, and you're going to want to do that. It was introduced in 2016, but starting in 2017, the Query Store tracks wait stats too. That's the first thing that we talked about. Well, it now tracks those wait stats per query execution. It's a great way to find out, wow, this query ran really slowly last night at 2 a.m. What was the issue? You can go see the wait stats. That's a SQL 2017 feature. And so it tracks the performance of query execution, not of the execution plan. And that's a really distinct difference. And I know I'm not exactly breaking new ground here talking about Query Store like it's not a 5-year-old feature, but if you're not already using this, this is really useful. It can detect when a query has suffered degradation in performance because its plan changed. And so it does the tracking by the query, not by the plan. The plan is all we had earlier. So while the worst plans in cache had been a strategy to identify the most expensive, is now one step better, finding the worst queries regardless of plan, for example. Okay, so what's the next logical step? So if SQL Server can tell me information about a query that has regressed because it changed its plan, and Query Store keeps around a history of execution plans and can compare them, say, hey, this plan was way better than this plan, couldn't SQL Server just automatically go choose the best plan every time, not just the current compiled plan, but a plan from throughout history, like one of those Star Trek episodes where they have to go choose a captain throughout time? I know, those are annoying, but the Query Store is actually way better. What if SQL Server could actually use information for regressed queries in a history of those plans? It can. There's a feature that was new in SQL Server 2017 called automatic plan correction, and Azure SQL Database, the PaaS offering, actually already does this for you by default. That's one of the cool performance things that Azure SQL Database actually got before the SQL Server product did. So automatic plan correction or automatic plan tuning is based on the Query Store, and it forces a query from a newer, slower plan to an older, faster plan. In SQL Server, though, it's not on by default. You have to enable it. You can accomplish this manually yourself too. There's more DMVs for that. The query automatic plan correction feature has its own set of DMVs, including DMDB tuning recommendations. And there's a great sample of how to go query that data yourself so that you could write your own, roll your own automatic plan correction if you really wanted to. Okay, I know I've covered a lot of ground in the first 27 minutes. At this point, Tracy, are there any questions that we could address right now?
There's nothing in particular question-wise, but we did have a nice little discussion about MaxDop in chat. So I was going to ask you to clear up the different functions different ways that you can do MaxDop. So
right,
we were discussing that, in 2019 you had the database scope. What prompted it was the fact that you said you can do it in Resource Governor, and the person didn't know that. So why would you do it in Resource Governor versus the database scope versus at the query level with the option?
Yeah, great
So
question.
all three of those options came up in chat. So
Mhm.
I just wanted to make sure that everybody was clear on why you would use them in different places.
Let me give you a really good scenario for the Resource Governor. Let's say that you have a suboptimal architecture where you have a lot of heavy reads and a lot of heavy writes happening on the same tables. Like ideally, you want to split up those workloads with a replicated copy or an availability group synchronous replica or something like that, right? You want to separate your heavy read from your heavy write workloads. But let's imagine that you can't do that, or you're growing and you're having growing pains. So enterprise feature Resource Governor would allow you to identify queries coming to your write database that are coming from a reporting system and say, hey, you heavy read queries, you got to go MaxDop 1. I can't have you going unlimited MaxDop on me and choking out my SQL Server CPU. Hey, you heavy read queries, you can only have 20% of my CPU. You can only have 20% of my memory. And if that means those read queries perform slower, so be it, but at least I am protecting my critical write workloads. And that's the key with Resource Governor. You want to look to kind of squash things and protect with unlimited access. You want to protect the most critical workloads you have. So if you can identify queries coming in from less important systems throughout the day, that's what you use Resource Governor to go and govern those things and protect everything else. You don't want to put Resource Governor on the things that are most important. You want to limit the things that actually don't. And so that scenario where you have a lot of reads coming in from an SSRS server or Power BI connection, and you can identify these things by all sorts of different ways, by logins, by host name, by application name, all sorts of different ways. Resource Governor is not a security feature any more than a logon trigger is a security feature, because you can't trust the host name and application name coming in from that kind of stuff. But it's a really good way to protect your critical workloads when you have to share the same instance for them.
Okay, so while
good scenario there. Yeah,
sorry.
and I'll say this: there's other cool ways coming to do this.
Well, the one I suggested too for the Resource Governor is because the database scope came in at 2019, is you don't have it in 2017 and below as well.
Yeah.
And you wouldn't want to do the query hint because, like, if you're coming out of SharePoint.
Right. It's
That's all
tough
I
to
gotta say about that.
maybe tough to identify all those. Yeah.
Or
and-
even
and-
an ORM or some other application like that.
And again, my
Yes.
condolences if you have to deal with SharePoint, but
Or ORM.
that's my old consulting speaking. Oh, and in Azure SQL database, of course, you can't do it at the instance level. There is no server level really to speak of at the Azure SQL database. There are these concept of logical servers, and they can share logins, and that's how you access them in the portal. But really, in Azure SQL database, each database is its own thing, so you can actually only set the max stop at that database configuration level or the query level. But if you don't want to change, or you can't change the queries that are coming in to apply a query hint to them for max stop, Resource Governor is a great way to do that. And unfortunately, Resource Governor is not a feature in Azure SQL database, although behind the scenes it is used. You can't actually address the Resource Governor yourself in Azure SQL database. But I wasn't sure what context your discussion was in. Anything else we need to discuss there?
Not on that question, no. I like I said, it just went back and forth on Resource Governor stuff, so I figured in Mac
good.
database configuration stuff, so I figured I'd let you weigh in on our discussion.
Yeah, great conversation. Anything else that's come up?
Yes,
move
one more
on.
question. I
Go ahead.
assume you wouldn't want to turn on automatic plan correction if a query will require many different plans depending on the parameters.
That is not a common scenario where you have a query that needs to be, I guess maybe you're using plan guides in this case. In which case plan guides would override it anyway. So that's not a common pattern. Usually you'd want to have a query plan that runs well for all sorts of different parameter loads. So for example, you have a query that with one parameter returns one row, and a query with a second parameter returns 1,000,000 rows. You'd probably want to try to find a good query plan that serves both of those well, as opposed to one well and one really badly, right? And that's what the automatic plan correction can help do. I'm not sure I'm answering the question, but in that kind of case, which is not uncommon to have that kind of case where you have one plan that generates, you have one query that generates wildly different plans depending on the first parameter set that's passed to it after a reboot or something like that. You might want to use one of the optimize for hints at the end of the query to optimize for a specific set of parameters, or optimize for unknown, which is pretty handy. Just, hey, pretend this filter doesn't exist. That can actually be pretty helpful too in that scenario. But we're getting a little off topic with that one. Let me know if you have any more specific questions on that. I'm going to go ahead and move on.
That was all the questions anyway, so you're good to go.
Cool. Thanks, Tracy. So DM exec sessions. This is actually something that is helpful for Resource Governor. So good transition here. This provides for queryable session info. So you don't have to do any of the functions like host name or application name or login name. This returns all of it in a queryable format for you. It replaces the old system view sys.sys processes. And in fact, whenever you see anything that sys something without the dot between it, it means it's probably old and deprecated. And so sys.dmexec sessions replaces that old sys.sys processes. And this is often joined to sysdmexec requests. So sysdmexec sessions, requests, sessions, and requests. We have a query in the toolbox called sessions and requests, very helpful. And it replaces SP-who, SP-who2, SP-who is active, stuff like that. All the different versions of this, and I wrote my own, and there's a bunch of different versions like this to go get what the active requests are, all based on these two DMVs, sessions and requests. This is the main hub for a lot of other DMOs to provide request info. Again, it provides that SQL handle and the offsets, these are integers, to identify the statement within a batch or stored procedure, and then use the sysdmexec SQL text to pull the actual text of that statement out and present it to you. Very useful stuff, right? You don't have to go to multiple calls or multiple features to get all this. A good sessions and requests query, and I'm not selling my own, but a good sessions and requests query will show you all the information that we've just talked about. It will also show you blocking information. So the reason why I wrote my own sessions and request query based on these DMVs a long time ago was for something that looks just like this. And this is a more than 10-year-old screenshot at this point. Or no, almost 10-year-old screenshot. I just set a reminder for October 12th to be the 10-year anniversary of this screenshot. Because I've used this in every demo of this presentation I've ever done. So this was a huge blocking chain, as you can see. Now, if you just look at the rightmost column, the blocked by column, you'll see what you typically would see out of SP-Who or SP-Who2, just blocked by. But just eyeballing that column, well, it's actually really difficult to see what's the root of the blocking, right? Like what's actually causing all this blocking. If only there was some way to figure out what actually was blocking the most things and itself was unblocked. So my sessions and requests query orders the result set by the length of a blocking these chain, which is a concatenation of all the other sessions that a session is blocking. So you see the first row is session 623. And if you look down the right-hand side, you'll see all the things that 623 is blocking. Those actually appear in the blocking these in a comma delimited list. And this is ordered by the length of that list descending. So the thing with the most blocking should trickle to the top or near the top, and anything that's blocking is going to be at the top of this result set too. So here we can see, 137 was one of the things being blocked, and so it wasn't 137, it was actually 623. It was a runaway SSRS report. And so we went and killed 623, and wham, everything just cleared right up from a blocking standpoint. But otherwise, if you only had access to that blocked by column, it'd be kind of difficult to do that. That's the kind of thing you can do when you start rolling your own DMVs queries, right? So you can use so what are some of the cool stuff you can do with DM exec requests? There's a %complete column that gives you a percentage of completion for backup and restore operations, and also for DBCC check DB operations. This is a great way, if you're dealing with a corrupt database, for example, to see, hey, this check DB has been running a really long time. Is it actually still doing anything, or is it stuck? And if the %complete column for that DBCC check DB hasn't changed in an hour, you have a bigger problem, right? So combined with the start time of the request, there's also a start time coming out of sysdm exec sessions. That's the login time, right? Or the login time coming out of that. That's when the session was created. The login happened, but the request start time is when the actual progress bar started on this request, on this statement, when you hit F5 or Control-E or whatever it is that you did. So combined with the %complete in the start time, you can get an estimated completion time. So even if you're not using the database backup or restore dialog boxes out of Management Studio to get a progress bar, you can get one of these out of the DMVs. And there's a real simple lab backup restore progress that does some of the math there for you, that you can see the estimated completion time of an in-progress backup. And keep in mind, when you're doing a backup and you're doing the verify only step of a backup, that's actually a restore, the restore verify only. And so you're going to see the progress bar go through twice to go and see first the backup and then the restore verify only. And that's expected, and you should do that every time. So next, sysdm exec input buffer. And if you're an old DBA like me, you recognize DBCC input buffer. Well, that's how I used to go get the text of whatever's happening right now. Well, that old DBCC input buffer has been effectively replaced by this new dynamic management function. So this is a DMO that accepts parameters. So it's not technically a DMV, but again, we can make more jokes about DMVs. This is a DMF. It accepts parameters. And this you can use to display, you can pass in the session ID, and you can use to display the, or the request ID, I forget, the last command issued from this session. It's the session ID. So you can go and get the last thing that was passed into this session, even if that request isn't doing something. So if there's a connection still open, but the command has finished, you can go see what that command was, what the last thing that was passed into that session was. Okay. Enough about exec and requests and sessions and stuff like that. You've got some really good fodder to go after there. Again, the sessions and request query is one of my favorites. Index DMVs that you should know. So we're going to break this down into 3 categories, and we're going to go through this. Again, not a lot of this is brand new. We're going to talk about physical stats. That's for index maintenance. That's fragmentation. We're going to talk about missing indexes and index usage stats. Missing indexes help you design new indexes. Index usage stats help you evaluate existing indexes. So first, DMDB index physical stats. This helps you measure fragmentation, and it replaces the functionality of DBCC show config to an extent. That's a pun. An extent is 8K pages. And so, well, these jokes are getting old. We'll show you some tables without clustered indexes as index ID equals 0. Index ID equals 0 is a heap. You shouldn't see these. have an whole other argument over an hour if you'd like about designing heaps intentionally in SQL Server. I don't think you should. Almost always, heap is a poor design or an oversight. However, index fragmentation numbers for a heap isn't really meaningful. A heap doesn't have an order, so it can't really be defragmented in a meaningful or helpful way. Index ID equals 1 is the clustered index. Now, this is whether or not it's a row store or a column store index. If it's the clustered index, it's index ID equals 1. And then index ID 2 or greater, those are non-clustered indexes. Again, whether or not they're row store or column store indexes. So that's how you identify the information coming out of this DMV. Average fragmentation percent is on a scale of 0 to everything's in perfect order to 100, everything is out of perfect order perfectly. Perfectly fragmented, and that's actually really bad. You don't want to see that, but in general, the higher the number, the worse. You may find it beneficial to perform some sort of index maintenance when the fragmentation percent is greater than 10. That may actually be overkill. There's various recommendations out there about when should you do index fragmentation. It probably has a lot to do with your storage subsystem. It has a lot to do with how quickly the fragmentation is being introduced into your tables. You may find a better balance of meaningful performance protection and logged maintenance activity with a less aggressive maintenance threshold of maybe as high as 50% to see the fragmentation actually protect performance and still getting a meaningful maintenance window out of the way. So again, if you're super old like me, alter index reorganize has replaced DBCC index defrag, alter index rebuild replaces DBCC DB reindex. Nobody should be using these things anymore. They've been deprecated for almost 16 years. Alter index rebuild all will rebuild all the indexes on a table. That could be a helpful saver there. And it also updates the stats, but it's not recommended because even though it might be helpful in some cases, like if you're doing an overnight ETL and you've done a lot of work on a table every night and you go and do all the indexes, for the most part, you actually only want to do index maintenance. You only want to remove fragmentation on the indexes that need it. And then potentially, if you have partitioned tables, you only want to do index maintenance on the partitions of specific indexes and specific tables that actually need it. You don't want to do what the old maintenance plans did in Management Studio in 2014 and before. They couldn't filter out for the average amount of fragmentation, and they just did fragmentation, defragmentation on the entire database. You don't want to do that. You want to be smarter about that. You want to have a more intelligent index maintenance strategy. So ideally, you will rebuild or reorganize only the most fragmented partitions of indexes in every maintenance window. You want to take the top off of a stack, and you want to run this maintenance window as often as you can, maybe an hour every night. And so you can do this with custom scripts. But for example, if you have newer versions of Management Studio and newer versions of SQL Server, on the right there is the old rebuild task in SQL 2014. As you can see, there are no filters there for fragmentation level or anything else. You were doing index maintenance on the entire database. Extremely wasteful, would not scale at all, and you'd hit that pretty quickly. As opposed to the maintenance plans that have been introduced in Management Studio since. So for example, in SQL 2017, this isn't even showing the most recent version, you have all these filters at the bottom that allow you to scan for a certain amount of fragmentation or a certain page count. You ignore indexes that are too small to care about, or you can even see if it's been used in the last however many days. That's potentially useful. And so these maintenance plans since 2016 have dramatically increased in their capability to perform complex conditional index maintenance operations. And you can configure reorganize or rebuild tasks to maintain only the indexes filtered by a specific fragmentation level or page count, for example. And this is all driven off of DMDB index physical stats, whether you're doing this with a third-party tool or maintenance plans or your own scripts running in a SQL agent job. Everybody's using this one DMV. And this is a DMF actually, because it has parameters. So there's a mode parameter in there, and by default, it's limited, which is the fastest, and it only scans branch level pages. It doesn't scan the leaf level pages. And if you remember a B tree, the leaf level is where you have a lot of the data, but the branch level is where all the binary decisions are made. Limited only figures out the fragmentation of those things. So it gives you a good approximation of the fragmentation level, but it's not a perfect number of what the fragmentation is. To get a more perfect measure of the fragmentation, you got to go from sampled all the way down to detail, which scans all the detailed pages. But this more accurate number is not useful, right? So just leave it in limited mode, get a decent estimate of that fragmentation level, and do index maintenance over a certain amount. Otherwise, this DMF actually doesn't populate some fields. You don't usually need these fields unless you do the detailed mode parameter. You don't worry about that. Keep in mind, though, of all the DMVs that we've been talking about today, this is the one DMV that actually hurts when you run it. Everything else that we've talked about so far, everything else that we're going to talk about, doesn't have any impact on your server whenever you execute it. It doesn't take up a whole bunch of resources. Even the limited mode of DMDB index physical stats, though, can. If you open up perfmon and you start looking at a bunch of SQL Server metrics, like pages and memory and CPU and the disk weights and stuff like that, running this DMV will impact your production server. So you don't want to do this during the day. You want to do this during index windows. You want to do this during maintenance windows. You don't want to just go and measure this during the day. So like right now, don't go run this DMV because William told you to do so. Wait till tonight outside of business hours if your business has a cycle like that. So let's look at a little lab about this. This is actually one of the labs I am going to do. So I am going to look at this DMV's fragmentation. So to set this table, I am going to create a simple table. I am going to create a primary key and a non-clustered index. So I got a clustered and a non-clustered index. And then I'm going to insert about 250,000 rows into it. There it goes. And I'm going to get my row count out of it when it's done. There we go. I got about 250,000 rows. And let me go look at our fragmentation. So this is one of the scripts in the toolbox that I talked about. It is defrag.sql. And at the heart of it, you see it has a whole bunch of other system tables and system views. And at the heart of it is our DMV that we're talking about right here, our DMF, sorry. And you can see that I'm using the limited mode. I don't even have to put limited, it's a null, but I'm passing in specific objects from indexes and partitions, and I'm getting all this really good fragmentation data out. Let me go ahead and run this, and you can see that I've got my table right here, fragmented table, and I can see the fragmentation level that I have, and I can see the page counts, and et cetera. And I can see the row counts, and something is creeping into the back of your head. And something is making you say, because you have good DBA instincts, well, William, all you did was insert 250,000 records. How is your table perfectly fragmented? It's got 99% fragmentation. What have you done? And that is the thing that is bothering you right now and will continue to bother you until I answer this question. And if you stare here at this code long enough, you will see the reason behind my perfectly fragmented table. And in a live audience, people would start shouting and tearing their hair out and stuff like that, trying to make me stop doing this to a good SQL Server database. But it's in fact that I use the unique identifier and the new ID function here. I have introduced a random key as the clustered index of my table. And so every row goes in a perfectly random order. It's not sequential, which would have the result of no fragmentation being created upon insertion. It's perfectly random, which means that all the fragmentation is created, right? I've got almost perfectly fragmented table here, and I only did inserts. I didn't update anything. I didn't delete anything. Those things usually introduce fragmentation, right? So let me do it the other way. I'm going to create another table. I'm going to use an integer column like a grown-up, and I'm going to use an identity function here to just give me a 1, 2, 3, 4 as I go down the table, and that becomes my clustered key. And I'm going to use that new SQL 2019 thing I told you about, the optimized for sequential key. This is how you do it. It's pretty cool. It also works in Azure SQL Database. Let me run this, and I'm going to insert the same data, the same number of rows, 250,000 rows or so, just with a simple loop. And let me go look at the fragmentation now out of a table that was designed that wasn't by a crazy person who does bad things to databases. And now look at my fragmentation level. Same data. I inserted the same number of rows, and just because I chose a sequential key, my fragmentation after inserting that many rows is only 3%, negligible, not going to impact performance. And most importantly, you can see that the page count, and this varies depending on the disks that are underneath it sometimes, but you can see the page count is smaller. I'm actually taking less data, less pages to store the same data. And if I do it again, I'm going to get a slightly different number. Maybe it'll be better, maybe it'll be worse. But as you can see, I have to do it again. This is repeatable. I've done the table again. I've got 2.6% fragmentation and less pages going for it, right? So fragmentation has a real impact. Now you're saying, well, I heard about this thing that a developer told me about called the new sequential ID function, which uses a unique identifier data type, but only puts in sequential GWIDs. Huh. Yeah, okay, cool. Let's try it your way. Let's do this with a unique identifier. I'm going to do the same exact thing, same exact code, put in 250,000 records, same randomized data, and let's see what kind of fragmentation I get there. And you can see that this non-sequential or new sequential index right here, it has low fragmentation. It has accomplished the goal of inserting data that is sequential, even though it's a unique identifier. But notice the page count. I am now still spending 16 bytes per column to store a unique identifier when I could have stored 4 bytes per column to store an integer, like a grown-up, right? That's 4 times the storage to store a unique key, which doesn't necessarily need to be there. And of course, the bigger problem here that I'm not going to do right now is that as soon as I restart this box, it gets assigned a different NIC MAC address because it's a VM or it's a hypervisor, which assigns it a new NIC every time it restarts. And everybody, of course, runs VMs. The seed for that new sequential ID changes. And so now my sequence has a different starting time. And sooner or later, I'm inserting rows at the beginning of the table again. I'm inserting rows in the middle of the table again. I'm not inserting rows sequentially anymore. So the entire new sequential ID function is a giant farce. Please don't use it. It is not the solution. Please design your tables with identities and sequences like a responsible person would. Now, I have proven to you beyond measure of a doubt the superiority of a good old integer and identity column. Why did the Windows 7 release candidate download page break? And if you haven't read this, it's an old article. And there's a link to it right there on Paul Randall's blog. It happened because somebody did exactly this. They had a table that was being populated and it had a clustered index on a unique identifier. It became so fragmented that requests against that table started timing out because they were taking more IO to get back the same data. This still happens in modern products, including CRM. You still see unique keys stored as random GUIDs all the time. It has a performance impact. We could have a whole nother hour-long argument about that as well. If you'd like to, we can schedule that at a different event called Argue with William about GUIDs and designing heap tables, but that's not what this presentation is about. So moving on, I guess I should stop for questions there. Any questions right now, Tracy?
One question came in is what's the ideal of the flag for the index creation?
Flag for the index creation. I'm
I don't know if they need to be more specific on that or not.
Yeah, throw that question in the chat a different way. I'm not sure how to answer that. But let me go ahead and keep moving on because I am, wow, I'm already at 50 minutes. Awesome. Okay, on the topic of index fragmentation and to measure it, we've been talking mostly about row store indexes, right? Column store indexes, extremely useful, and everybody should get used to dealing with them, have their own DMV for fragmentation. And you need to include this DMV in any of your custom maintenance scripts that you've written if you have column store indexes. And since SQL 2016, column store indexes are writable. They're great. They make performance really good for certain conditions. This wasn't really the case. Fragmentation wasn't really something that you had to worry about in 2012 or 2014 because column store indexes were for the most part read-only. In 2014, you could do the clustered column store that was writable. But if you're doing index maintenance and you have column store indexes, you actually have to use a different DMV here. You also may find it necessary to reorganize a column store index multiple times. And by the way, you only do reorganize. You don't rebuild the column store. That's actually wasteful, not necessary. You do reorganize instead, but you have to do it 3 times. And you'll see this, and if you monitor this DMV, you'll see this as the data pages move into their tombstone status and eventually get out of tombstone status. An important distinction to make, there's a script in the lab there. Make sure you are maintaining your column store indexes just like you would your regular indexes. Okay, Tracy, any clarification or any new questions coming in?
No.
Cool. Let's keep rolling. Okay, missing indexes. This was my favorite feature introduced of SQL 2005. Again, I know I'm not breaking a whole lot of ground here by talking about something that's 16 years old, but this DMV set still remarkably useful and at the foundation of new features that are being introduced to Azure SQL Database. It's a set of dynamic management views that record whenever a query plan recognizes the need for an index, specifically a non-clustered row store index, and we're not talking about any other type, that could have helped performance. So for example, an index scan that could have been an index seek, SQL writes down on its wish list how much that index would have helped, things like that. It recognizes the need along with estimated stats on the cost and the percentage of that cost that would have gone away. And so we have three indexes here, three missing indexes, DMVs here, that are already running. They're already gathering information. They don't need to be enabled. You can go look at them right now. These are lost, though, when a server is rebooted. Again, rebooting a SQL Server instance is not a performance tuning step. This information and a lot of other information from a lot of other DMVs that we've talked about so far, by the way, are all lost when you restart an instance. They're also, in this case, cleared out for when a table is altered because you change a data type or change a column out or something like that. It wouldn't want to present you out of date recommendations for indexes. So it wipes all the missing index recommendations for that table whenever you do alters to that table. And it only recommends, again, row store non-clustered indexes. It won't recommend that you how to design a clustered index on a heap. You have to fix that by being a good database designer. And then it won't recommend any other type of index like a column store, XML, or spatial index. But it does generate a lot of really good information. However, it must be used with sobriety. Don't create every missing index suggestion that comes across, or your rights will suffer. Non-clustered index exists physically as copies of the table, and they must be kept up to date too whenever you write to the table, and thus they are overhead every time you write to a table, insert, update, or delete. Rights can benefit from a non-clustered indexes when the source query for the write, like insert into, select from, blah, 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 when that source query is improved. So don't just think that all your rights are going to suffer whenever you add indexes. It's actually going to help a lot more than you think sometimes. Indexes should be created to help many queries though, many suggestions. So the last thing you do is go start creating indexes for a single query or the whatever query or view or report that you're troubleshooting right now. Suggestions in the missing indexes views may only differ by columns in the key. Like maybe they'll have a recommendation that you put an index on the same table, column A, and another one for column A and B, and another one for column A, B, and C. Or maybe the includes differ. Well, in that scenario, creating only that last index, the index on columns A, B, and C, with a superset of all the columns in the include, would be the perfect index because it would satisfy all the different queries, again, many different queries that generated all of those index suggestions, right? You want one index to serve many queries well. So you're going to combine suggestions together by kind of factoring them down by the index keys so that you get a common key column list in the same order, and the order of the key columns does matter. And then you combine the includes lists where the includes columns order does not matter at all. You can then, before you create the index, you then combine it with existing indexes on the table. Maybe there's already an index out there that just doesn't have that new column that you added. And that new column is used in a whole bunch of new queries. And so this new index is going to replace an old index. And that old index isn't serving up queries anymore. If you ever add columns to a table and you notice that performance really drops and you're not understanding why, it may be because the existing non-clustered indexes, which were perfectly tuned before, are now missing a key ingredient. You could see that same thing happen with column store indexes, by the way. When you have to jump from a column store scan back down to a non-clustered row store index scan, that performance is jarring, right? That difference is jarring, and it may just be because that new column didn't get added to the non-clustered column store index. So be careful, though, not to change any uniquenesses. You would not want to combine a new index suggestion with an existing index that is unique. Leave your primary keys and leave any other unique indexes on the table. You can have multiple uniquenesses enforced. Leave those alone. You don't want to change the programming of your database, right? So when do you look at missing indexes views? You look at these after actual usage has been recorded in production. In other words, don't do this on dev or test, because you're going to have queries that aren't going to be there in production. You're going to have developers testing things. You're going to have QA people testing things. That's going to be misleading. So you don't look at missing indexes views necessarily in dev or test, or you just be real careful. You do this during user testing if you're simulating actual usage, right? And you can actually put a time boundary to look back, and you can only look back, say, only show me missing index suggestions that were generated today. There's a filter in there for that in this DMV's output. Do it on your production environment after a stable period of active and typical activity, and try to capture an entire business cycle. It's not the first time we're going to talk about this idea of knowing your data's business cycle. For example, if you're doing data that has to do with payroll, know when payroll is paid. Do they do it monthly, weekly, somewhere in between? Know that, so you could capture an entire business cycle and then start taking action on the indexes based on an entire business cycle. So know if your business cycle is a month or a day or a quarter or something like that. And by the way, Azure SQL Database has been giving you index recommendations in the Azure portal based on these same missing indexes DMVs. There's a sophisticated level of automation on top of this. It doesn't just go out and slap on indexes based on missing indexes alone. It actually has some more logic, and it's quite conservative about when it applies new indexes, but it will do it given a strong enough signal. And then a final note on missing indexes views, and I think we've all seen this green text pop up in Management Studio at some point. Since SQL 2008, missing indexes views have been integrated into the show plan to kind of tip you off that, hey, there's a missing index here that could help out this query. But like we just talked about, you want to create indexes based on missing index information for a lot of different queries, right? So whatever you do, don't create the index that Management Studio is recommending here. Just treat this as an alert to go and look at missing indexes holistically across your entire database and create indexes based on the whole picture, all the traffic, all the queries coming against your database. And there's a lab there that you can use to help set something up and then observe the missing index activity. Okay, so we've talked about index fragmentation. We've talked about how to create new indexes. Let's talk about how to evaluate the usefulness of existing indexes. So DB index usage stats tracks access operations across all indexes and heaps cumulatively. This data resets when the instance is reset. Again, you lose this data whenever you reboot the SQL Server, so try not to do that for performance reasons. And if you know you're about to reboot your server one night, you may want to capture this data to your own tables, warehouse this yourself. This data is retained through maintenance operations and other types of operations, so it really is a valuable piece of information. And again, it joins to other system tables like sys indexes, sys objects, and things like that. So when do you look at the utilization, at the usefulness of existing indexes? Well, I'm sorry, how do you look at this? And the when is the next slide. How do you look at this? You look for values in the user lookups, user seeks, and user scans. Those are reads from the index. That means this index is being used. It's helping you somehow. Seeks better than scans, obviously, but at least it's being used. So if you see zeros under user lookups, user seeks, and user scans, this means this index isn't being read from. Nothing is actually benefiting from this index existing. And then the user updates column gathers all the writes together, right? The inserts, the updates, the deletes, and that tells you how many times this index hurt you, that you paid the overhead for this index to be maintained along with the rest of the table. So if you see 1 million user updates and 0 user lookups, seeks, and scans, this index isn't helping anybody. This index needs to go. This index needs to be dropped. It needs to stop taking up space on disk, taking up space in backups, taking up time in maintenance plans, taking up space in memory, right? So this criteria could be different based on the intended table's usage. Like maybe we're expecting a whole lot of activity to this index and it's not getting very much. Maybe we'd be more critical with that. But at the very least, if you know it's not being read from, after a significant amount of time, you can drop it. Similar to the missing index DMVs, you have to know your business cycle. So only look at this information and take action on it after a stable period of actual production use that covers a business cycle. Again, critical to know the business cycle of this data. Is it weekly? Is it monthly? Is it quarterly? If you have a big quarterly cycle of data that happens at the end of every quarter and you drop indexes critical to that cycle because you hadn't seen any of that activity in the last month, you're going to be in for a world of hurt at the end of the quarter. So make sure this DMV is capturing information covering an entire business cycle, or at least store that information up until it covers an entire business cycle. So again, those are your index DMVs in summary. Your physical stats to evaluate the fragmentation, missing indexes to help you design new row store, non-clustered indexes, index usage stats to help you evaluate existing index usage. Now, I'm going to go through a whole rapid fire round now where I only have like 1 or 2 slides per DMVs, but it's only the choicest and rarest hand selected organic DMVs that I'm going to be presented to you, stuff that you might actually find useful. So SysDMOS performance counters. These are query perfmon stats from within inside T-SQL. So you don't have to open up perfmon. You don't have to get WSQL or WMI drivers going. You can actually use perfmon stats in tables and query them inside your SQL Server. And so this replaces and is way better than sys.sysperf.info. It includes hundreds of the SQL Server metrics, or the MS SQL and then $instance metrics that you would see in perfmon, but you can now query them inside SQL Server. It unfortunately doesn't have things like CPU and physical disk and other types of metrics that are at the server level, because this only has access to SQL Server level perfmon metrics or WMI metrics. And you can see which ones it has and doesn't have, but this is actually really useful to get some information. It is slightly more involved to get this information out for some metrics. So for example, buffer cache hit ratio, which is a common thing. It's not a perfect measure. It's not even a total picture of the memory usage of the server, but it's something worth looking at sometimes. Buffer cache hit ratio actually comes out of this DMV as 2 numbers, and you got to do some division. It doesn't come out as 1 number. It's a little tricky there, but you just have to know. There's a lab here. Page life expectancy, really valuable. That's one of the most common use cases for this DMV, is to get that out and track it with your own things inside your own SQL Server instance. SysDM performance counters. Okay. SysDMOS sys memory includes total and available physical memory for whatever server that the instance is running on, including that page life expectancy and a lot more memory related data. It also has these high-low memory flags, which are part of the Windows virtualization suite. It can actually signal to your application when the Windows server has memory available or when it doesn't. And you could use this DMV to tell your application to scale itself up or down, perhaps in concurrent threads and stuff like that, based on internal flags coming out of memory for Windows. This is actually pretty useful stuff that you could use to make a more intelligent application. SysDM host info. I told you I'm going fast, like one or 2 slides per. This includes host information, including both version info for Windows and Linux. This was introduced in SQL 2017. It replaces SysDMOS Windows info, and that's obvious. We had to have a new DMV come out when we introduced SQL on Linux. So you have information for both platforms out of this new DMV, SysDM host info. And this is a really good way to kind of do inventory and categorization of your instances that you have under tenant, in case you had to rebuild them because of a ransomware attack or something like that. You can use this to query and get the exact information out of what OS was hosting each SQL instance. It's definitely something that should be in your inventory of servers that you manage. SysDM server services allows you to query the state of server services inside SQL Server. So you could use this to find certain things like agent. How long has agent been running? Is agent running? Things like that. It doesn't have everything. I don't think, for example, the poly-based services are in this yet. But it is useful in certain cases. You could see how long the SQL Server has been online, for example, via this query. You could also see whether or not instant file initialization has been enabled as of SQL 2016 Service Pack 1. That's really useful. The old way of figuring out whether IFI was enabled was actually kind of tricky and time consuming. This is a really good yes or no flag that tells you whether or not IFI is on. And yes, for the most part, IFI should almost always be on unless you're in very high security physical storage environment. Topic for another presentation, of course. SysDM server registry. This allows you to query registry keys from inside the SQL server. So you could see things like, hey, what's the location of my master error and mass log files, just as if you were seeing them with inside configuration manager. That's more cool than useful. I'll admit that. This is more useful than cool. SysDM OS volume stats allows you to see how much free space you have inside of disks where SQL Server lives. So you can't get information about volumes where you don't have any SQL files. So if you have just like a random volume attached to your server, but SQL doesn't have any files there, it's not tracking that. You can still use XP fixed drives to get that. But this is where you can go to get information about how much free space you have. And you could set up a job to monitor production space volume. And you can get an alert whenever you got less than 10% free, and you don't have to do anything with WMI or anything like that. You can get all of this from within SQL Server. DMDB log stats. This is new in SQL 2017, and they introduced it for Service Pack 2 in 2016. It's a handy one-stop shop for all sorts of things in transaction logs, including your VLF counts, the log reuse reason, when the last time the backup happened. And so it replaces things like DBCC log info, which is now deprecated. If you've got old maintenance things based on DBCC log info, try to rewrite them with this new DMV. You're probably going to find some new features that are superior in there. DMIO virtual file stats includes an ascending counter that can be used to measure the data volume over intervals. And this is a way to figure out which databases are busiest. If you're doing a server migration, for example, for that SQL 2012 instance, you're probably going to be asked, hey, is this database used anymore? This is a great way to go and ask this. Now, one thing, maintenance will still run up the numbers on this thing. So if you're doing a rebuild of the database every Sunday night or something like that, regardless of the level of fragmentation, it's going to show activity, even though there's not really any activity in this database. Another reason not to do that. But this is a really good way to answer certain questions about IO, usage, other things like that inside of your environment. There's a good lab for that as well. Just a few more to go, and then we'll open it up for questions again. So SysDM OS ring buffers. This is a great way to access information coming out of X event sessions, including the default system health X event session, which is the only way to capture a deadlock that happened in the past that you weren't expecting. That's really useful. You know, back in time, you'd have to go set up a deadlock trace or put on a certain trace flag to dump a whole bunch of information to your log. Now you can actually go back in time and go see that deadlock, even if you weren't expected to look for it. As a consulting DBA, this is super useful. You go in, they say, hey, we've been having a bunch of deadlocks. You can use this deadlocks and X events query that I've got right there to pull up information from the system health X event session. From the ring buffer output to it, there's also one to get out of the XEL file. And then you can get to that deadlock definition that happened before you even walked in the door. Super useful. You can also get things like CPU utilization going back a few hours out of your X event session for system health using this DMV. Let's talk about availability groups a little bit. This SysDM HADR cluster, there's a bunch of DMVs for availability groups. This is kind of the core one. Some of them, it doesn't matter whether or not you run it on the primary or secondary, it just returns local information. Most of these DMVs, though, you want to run these on the primary replica of the availability group, whatever it happens to be at the time, because then you get information about the primary replica and information about the secondary replicas that are reporting in. So for example, you can see what the log redo rate and how far behind a secondary replica is and how long it'll take to get caught up, which is essentially your RPO, right? Or your RTO. This is really useful, and this DMV and a few others that I've listed here are really valuable for building your own dashboard, which is far superior to the dashboard that Management Studio gives you for availability groups. It actually has like a lot of numbers, not just green check marks behind it. It explains why a synchronous replica may be synchronizing, not synchronized, a lot more than just the suffix of that word, right? So really important that you understand if you have availability groups going on, and this monitor script here in the toolbox is a good first start there. using these DMVs. And then a couple brand new things for SQL 2019. I know brand new, it's like 2 years old, but these are the newest things, and I'm almost done here. SysDB page info is new in SQL 2019. This replaces most of what DBCC page was used for. And if you've only seen DBCC page in like a data corruption exercise or something like that, well, yeah, this is kind of one of those things. But the DBCC page isn't actually deprecated yet because this DMV does not replace it wholly. It only replaces it for certain types of information, certain weight resource types, for example. It really helps you, especially with this other new thing that was introduced in SQL 2019, FN Page Res Cracker, which helps you get information out of page resources. This is really good, useful diagnostic information for those who are troubleshooting data corruption and page issues inside. It's potentially really useful to you. Look that up if you're in that situation. And then DMExec external work, last one. This actually applies to Polybase, one of my favorite new features of recent editions of SQL Server. In Polybase, you have this concept of external pushdown computation, where you are taking aggregations, filters, and joins and executing those at the remote data source, at the other SQL Server or Oracle Server, or sometimes a MongoDB, or maybe even an Azure file store. And you are able to execute some of those filters on the remote side and then bring them back. This is one of the huge advantages of Polybase over linked servers, because linked servers didn't do that. Linked servers brought back all that data and then did the filtering, the joining, and the aggregation in the SQL Server, right? But it, meanwhile, had to bring back all that data, right? Polybase can really speed things up by doing some of that push down computation. SysDM external work allows you to see the query that was actually pushed down. There are some things that prevent pushdown from happening. It depends on what vendor you're using and what things go on in there and what syntax they support, what the actual data source is that's external. And if pushdown is happening, you'll see a where clause in the read command of SysDM external work. Now, SysDM external work's been around as long as Polybase has, but in 2019, they added this read command, which passes the actual query back to you that was executed at the external data source, so that you can see whether or not it's just a select star from, or it's a select star from where, blah, 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 blah. And that tells you that Polybase pushdown external computation was happening. Cool. Bunch of links that I use whenever I create a presentation like this. I always store them at the very end that may be helpful to you as well. Here's a couple books that I wrote for Microsoft Press along with an awesome team of co-authors. The last one came out right with the pandemic, did great for sales for the book, but those are out right now. Please support your local STEM initiatives. I encourage you to go and donate time and money to your local STEM education initiatives, wherever it is that you are from. I promise you there's somebody doing this type of work in schools or in the general community. Try to get involved. There was almost certainly someone running a nonprofit somewhere where you live that could benefit from your enthusiasm and your skills. This is the Futures Fund. It's a STEM education nonprofit local to me, where I'm actually from, that I still volunteer for remotely. Please reach out and share your knowledge with the next generation, and also especially with folks in your community that are needing to find new careers during the pandemic. And finally, here's the information about me. There's my blog, SQLTac.com, where you can download the slides and you can download the all the labs that I've mentioned, including the ones I didn't do. We have about 12 minutes left, right, Tracy?
Yep.
Great.
We only got 3 small questions. So
great.
Back when you were doing the DMVs for showing drive space and stuff like that, the question was, does it work with LUNs?
No, it can't see beyond the windows.
Okay.
So nope, it only sees what Windows presents it.
So
that would be pretty cool though, but that would also be tricky based on different vendors, but go ahead.
No problem. Another question was, is there any locking concerns when you're querying DMVs? Like, do you have to use no lock or anything like that?
Great question. And no, with the exception of the DBCC DBIO physical stats, right? And that's not a locking concern. That's just a performance concern. All these DMVs that I've talked about, except for that one, are safe to run at any time on your SQL Server. And there's no need to worry about locking or performance hit. The DBIO physical stats goes out and scans data pages in your database. it will chew up a ton of IO resources, and users may notice that. So again, that this is your warning, the physical stats, DMVs, don't run that during the day. Run that during your maintenance window, and then use the information to go and do your index maintenance right then.
Okay, back
Great
to that question that we needed clarification on. So I'll remind you of the question, and then I'll read what he gave me for clarification. So what was the ideal of the flag for the index creation? And then let me scroll down. Because we've talked since then about other stuff in chat. I'm finding it. He was talking about the feature optimized for sequential key.
Oh, that. Yes. What's the question? What is it?
I guess what it is, it was what is the ideal behind the flag, I guess, for the index creation?
Yeah, the idea behind it. Let me try to zoom
I
back
guess
up there.
what's its purpose? It says
The idea is that it has a big positive impact on it's around here in the lock. It's right after lock. Yes, here it is. Yes. There's a really good blog post that I have here. It's actually in the notes of this PowerPoint slide. So if you download the PowerPoint slide, there's a really good blog post talking about the sequential key stuff. If you just Google or Bing optimize for sequential key, you'll get a good blog post explaining some of the inside information on how this works. But the idea is that it prevents some of that concurrency on the page in memory. It's not the physical disk page, but the page in memory that is storing the hot spot, right? So if you have 9 rows in a table with an identity or a sequence, and you have 10 queries that are trying to insert a record into the table, they're all trying to line up to get ID 10, and then the next one's trying to line up to get ID 11, and so forth and so on. That causes page latch EX, this new flag, which you declare on clustered and non-clustered indexes, removes some of that hotspot pressure. And so when you have concurrent inserts, you won't notice this if you're just inserting a record into a table. You'll notice this if you have 10 windows open trying to insert a record into the table. And then it is measurably better, up to 30% better.
All right.
The actual science behind that, I don't know if I could do a better job explaining that, but there's the information out there. Good question though. It is new, and it's a breakfast thing you want to do. You're going to wake up every day and do that in the tables you're designing. I promise.
Then you got some compliments. So I'm going to read the longest one because it's long. So William, I absolutely love your presentation. It's not in caps. I'm not going to yell. A PowerPoint presentation with an exclamation point. It's a PowerPoint book in caps. And I think that's outstanding. There's been too many presentations with 6 bullet points and an hour info that's not available after the presentation. Totally awesome in caps. Right. Presentation. Good sir, exclamation point. It was a real pleasure, exclamation point. Fantastic.
Let me
just
talk
one
about
compliment.
Oh, that's just one. Let me talk about that. And especially if you're interested in getting into technical speaking, listen to that compliment that I just got. And I've gotten it before, that my slide decks are useful after the fact. There's a lot of, I did Toastmasters for a really long time, great for public speaking, and I totally recommend it. But their school of PowerPoint is just put a bullet up there. You don't want to take attention away from you. You want them listening to you, and you don't want them reading and trying to listen to you at the same time. Okay, I get that. But also, I'd like my PowerPoint presentation to actually be useful to somebody afterwards. That's why I kind of read from the slides sometimes, but I'm reading quickly over them. I'm summarizing them. But meanwhile, this thing is still useful to somebody after the fact, because I'm giving out 82 slides jam-packed with information right here. I know you're not going to gather it all from my mouth. My ego is not so large to think that I am the only source of truth here. That's why I put it in the slide, and I include a ton of links for you to go and look this stuff up after the fact, because I know that this presentation is fairly encyclopedic. So when you're giving your presentations, resist the idea to make your PowerPoint this cryptic summarization that only you know how to unlock. Make it useful to somebody afterwards, even if it's in the notes or the comments of the slides that you're not seeing when you do the presentation in presentation mode. Good feedback though, and thank you for that. It's intentional.
Very long compliment in it. Like I said, you got several others, and thank you for making it available and making their work life better and all this stuff.
Awesome.
So
I'm not sure if you said work life.
Big impressive one. So.
I appreciate that. I'm not sure if you said work life or work wife, but I think I've helped with both. Hopefully, I don't know.
Help me make things better at work right now.
Okay.
I'll
Good.
slow down and talk.
That's right, SQLtech.com. Yeah, I'm looking at the
Yep.
chat now. Great. Well, thanks everybody. Look, we have about 5 minutes left. If there's any questions, I'm happy to hang out. Otherwise, enjoy the rest of GroupBy. Enjoy the rest of your week. Stay safe out there. Go get your shot. Mask up until you do. And I appreciate it, everybody.
All right. Thank you very much. That was good. Clap, 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 clap. I enjoyed it.
All right.
All right. I think Pat's going to be taking over for me as far as the moderating position, and Jeff's up next talking about all kinds of crazy stuff. So
Sounds good.
he presented this Black Arts thing to my user group, and he went like 2
cool.
hours instead of like, we let him go as long as he wanted. It might have been 2.5 hours.
Oh, hey,
And it was
speaking of
just
user
mind
groups,
melting.
speaking of user groups, Tracy and everyone else who's listening, I have a presentation from Microsoft on how to contribute to Microsoft documentation via pull request on GitHub as an open source project. Super useful. Can definitely go on your MVP activity summary if you're applying for MVP status or getting renewed. Definitely something that is a real hot topic for a lot of people and pretty useful to allow the user community to contribute back to Microsoft presentation. Reach out to me at any method of communication that you'd like to get me scheduled to do that presentation from the Microsoft SQL Docs team at your tech user group or event.
Will do. You can be my first speaker next year.
Yeah, book it. Wait, next year? You're already booked for all the 2021? That's awesome.
All 3 of my groups are all booked through the year. So
Hell yeah, way to go. That's
I
fantastic.
I work hard for that at the beginning of the year.
Hey, Kevin Hill did that and his PR got merged. Way to go, Kevin. Awesome. I don't think I looked at that. I was looking out for you, but I don't, I'm not responsible for all the SQL docs as a whole team, but that's great, Kevin.
I finished some stuff a few years back on there for availability groups, distributed availability groups.
Yeah, when I was writing the book,
cool, I can actually stick it in there.
Yeah, that's what the PR is. It allows you.
It was missing some stuff. Right when it first came out, and it was still in preview edition stuff. So it was missing a couple steps. So I finished it up for you guys.
Awesome. Well, hey, thanks for contributing. That's how we scale out, and we rely on the wisdom of the community. So fantastic. You put me on the schedule for January 2022. I'm not above that. That's awesome.
All right. I will ping you.